Section 3.1 is going to deal with graphing and writing inequalities. That's the alligator symbol, where we say something is bigger than something else or something is smaller than another quantity. So we're going to take a look at those in this section. Alright, there's two ways to think about these inequalities, helpful reminders, cute little ways to remember it. If you remember that the alligator always eats the biggest fish, or biggest animal, or whatever it is, its mouth, its open mouth, is going to be facing the larger number. So you see the alligator is eating the 5 because it's bigger than 2. So this would be read, 2 is smaller than 5, or less than 5. 2 is less than 5. You see here now the alligator's turned around, and we would say 11 is greater than 10, or you could say 10 is smaller than 11. You can read them left to right. As far as using the actual math symbol, this is what we use. 2 is less than 5 is how we read that, or 5 is less than 2, or 5 is greater than 2. Or down below, 11 is greater than 10, which is also read 10 is less than 11. Alright, another cute little way I learned a couple years ago was you always laugh and point. You always laugh and you point at the smallest thing. So you look at it and you say, "Ah, you're so small." Okay, so that's why we would write 2 is, we're pointing at the smaller thing. So 2 is less than 5. Here we're going to point at the 10. We're going to draw an arrow toward the 10 because it's so small and silly. Alright, two silly ways to remember, goofy ways to remember which way to point the alligator symbol, called an inequality symbol. Alright, there's a lot on the screen, but I went through most of it, or at least half of it, on the previous screen. An inequality is a statement that says that two quantities are not equal somehow. So it's some sort of comparison. So for example, this column, this is the less than symbol. You see A is less than B, 2 is less than 5, 2 is less than 5 is how we read that. Here's the greater than symbol. A is greater than B, 4 is greater than 3. And here it is, 4 is greater than 3 written out in words. Now, if there is this little line here, you see that kind of looks like an equal sign? Well, that combines the idea of less than or equal to. So for example, 4 is indeed less than or equal to 6. It's not equal to 6, but the word or means either or. So 4 is either less than or it's equal to, and indeed that's true. It is less than. So 4 is less than or equal to 6. 5 is indeed less than or equal to 5. So let me write that on the paper here. 5 is less than or equal to 5 is a true statement. And that's because 5 is equal to 5. Less than or equal to 5. The word or means something. It's actually different than the word and. Here we have greater than or equal to. Same concept. 9 is indeed greater than or equal to 7. That's true, but this is also true. Let me write it out. 10 is greater than or equal to 10. Alright, this last one's pretty easy. This is called the not equal sign. So A is not equal to B. 11 is not equal to 54. That's a true statement. There it is written out. This screen attempts to explain the difference between or and. It's not, completely irrelevant here. We need to understand this. Let's say you're only going to get candy at Halloween if you are wearing orange or black. Okay, so someone who's wearing orange and pink would get candy. Someone who's wearing orange and black would also get candy because they're wearing one or the other. If they're wearing all black, they will get candy. If they are wearing only blue, they will not get candy. Now, down here, with the word and, if the person is wearing orange and black, both, so let me add the word both into there. That's what's going on here. Both, they will get candy. But if a person shows up in all orange, they will not get candy. If the person shows up in all black, they will not get candy because they don't have any orange, and it has to be both. If they show up with orange and pink, they will not get candy. If they show up in all blue, they will certainly not get candy. So sad day for them. Alright, you remember graphing dots on a number line. When I asked you to write x equals 9, you'd come over here and you'd put a dot at 9. That we did that earlier in the year, and of course, if x equals -3, we put a dot right there at -3. So we put numbers on the number line earlier. So we did review that earlier in the year. I'm going to erase that. Now here we have a statement that I want all numbers under 2 is what that says to me. X has to be less than 2. Okay, so think of this as a boundary. We're going to put an open circle at 2, and I'll explain the open circle here in a moment. But now we need to show where all the answers are. So where are all the numbers under 2? All the numbers under 2 are over here. So that's what I'm showing in this picture. You have to ask yourself, I want to be a winner. Who am I? I am smaller than 2. Well, then I must be -3, -2, -4. All these numbers down here are winners here. Now, the reason I put an open circle is because 2 is not a winner, because there's no equal sign here. So we have to put an open circle, a gaping hole, that shows that 2 is not a solution here. All the solutions are all the numbers under 2, which are way over here on the number line. That's why I drew this to the left. Okay, the next problem says all the answers are bigger than 6. So show me the answers on the graph. Well, what we're going to do is we're going to put an open circle at 6 and point it to the right. Open circle and point it to the right. Okay, these are where all the winners are. I want to be a winner. I am bigger than 6. Who am I? I am 8. I am 9. I'm 10.1. I'm all the numbers bigger than 6, but not 6. That's why I left a gaping hole here. It's called an open circle with an arrow pointing to the right. Alright, these examples have a slight difference in them. Notice that we now have an equal sign here. Less than or equal to, greater than or equal to. Let's see how the graph differs. Now, on the left one, this says winners are all numbers less than or equal to -5. So let's find -5. -5 is right here. This time I'm going to fill it in because -5 is actually a winner. -5 is a winner. Now, if I imagine myself right here, here I am smaller than -5. So on the number line, that's actually to the left. So the two tricks here are to really be careful with the negative number. The arrow has to point to the left in this case because I am smaller than -5 and small numbers are over here. And because this had an equal sign, we do a closed circle. Okay, on this next example, again, we're going to do a closed circle at -1. Now, I am bigger than -1. Who am I? Well, I am 9, I am 6, I'm 4, I'm all these numbers up here. So that's why we're going to draw a solid line pointing to the right, with an arrow pointing to the right. We can also translate a graph back to an inequality. Here I see answers are really big. See, they're all the numbers bigger than -2. So what we do is we write all the numbers on the planet so long as they are bigger than -2. Okay, and since this was an open circle, that's why I did not include an equal part here. Open circles mean no equal. This one's going to be closed circle, so we're going to write all the answers here. All the answers here are small. See, all the answers are in the small direction, so the answers, x, will be less than or equal to 4. So you can look at a graph and translate it into what we call an inequality. This is called writing the inequality. Sometimes you need to solve the inequality first, and we're going to use the same tools that we used when we were solving algebra equations. So we are going to subtract 5 on both sides. Here I'm subtracting 5. We get h is bigger than 4. We then draw a number line. Here's 0, here's 4, here's negative 4. And we are going to, I'm going to change color so you can see a little better. We're going to put an open circle at 4 because that's the boundary line, and then all the answers are bigger than 4, we determined here, see? All the answers are bigger than 4, so they are going to be to the right. So sometimes you have to solve it first and then graph. Using our algebra tools is how we solve it. Alright, I want to do one more example here. You see here the x is on the right side, so I want to show you how that plays out. If we add 1 to both sides, we end up getting this statement. Okay, x is actually smaller than 9 here. We say 9 is greater than x, or we can read that x is smaller than 9. So when we graph it, here's 0, here's 9. We are going to have to be very careful. We're going to put an open circle at 9. But do you see that the arrow points to the right there? That's not the way we want to point this, because x represents small numbers, and small numbers are over here. So we do have to think about each problem on which way the arrow is going to go.
Made with Doodlecast Pro.